The shredded cane enters the milling system. Multiple rollers press the cane. Each stage removes more liquid. Water may be added to maximize extraction efficiency.
This is where the process begins. Extensive fields cultivated with precision over many months.
Grinding is critical practice because sugar content peaks only for a short window.
Modern harvesting combines cutting, cleaning, and loading in one continuous operation.
The objective is efficiency and speed.
A tightly controlled supply chain connects field to factory.
The journey begins, not in the factory, but at its gates.
We bring freshly harvested cane directly from the fields.
Every batch is tracked.
From here, the cane enters the feeding system. We regulate the flow so the machines receive a steady supply. Too fast causes blockage. Too slow reduces efficiency. The cane undergoes preparation. First, it is washed, then shredded. Water may be added to improve extraction. The liquid is raw juice. The remaining fiber, bagasse, is used as biofuel.
Now the cane is cut into smaller sections, then shredded to break open the fibers. This increases surface area, making juice extraction more efficient.
The shredded cane enters the milling system. Multiple rollers press the cane. Each stage removes more liquid. Water may be added to maximize extraction efficiency.
What remains is bagasse, not waste, but fuel.
We burn it in boilers to generate steam and electricity for the factory. The raw juice still contains fine particles. We filter it to remove remaining solids. Only liquid continues forward. We heat the juice and add lime in controlled amounts. Impurities separate, slowly settling out. The result is clarified juice ready for concentration.
At this stage, the raw juice still contains impurities, fibers, soil, and natural acids. We heat the juice to a controlled temperature, then add coke limely, forming a layer we can remove.
We use a multi-effect evaporation system to remove water efficiently. Each with low pressure while lowering the sugar molecules.
The result is a dense syrup with high sugar concentration.
Now we transfer the syrup into vacuum pans. Under reduced pressure, we lower the boiling point, ensuring crystals. Later by year called masquite, crystals grow in a controlled environment.
We continuously monitor key parameters: moisture content, compression force, drying temperature, and duration.
The objective's consistency is intact during handling yet dissolve quickly in use.
The masquite is fed into centrifuges rotating at high speed. Centrifugal crystals remain while molasses is expelled through perforations. A precise separation producing raw crystalline sugar.
The process begins with refined sugar, uniform in size, pure in composition. But dry crystals cannot form a cube. They must first be conditioned. A controlled mist is introduced.
Inside these mixers, sugar crystals are gently tumbled. The goal is consistency, not saturation. Every grain lightly coated just enough to create cohesion. Too much moisture weakens structure. Too little prevents bonding.
Granulated sugar is conditioned with a fine mist of water or steam. This creates slight adhesion between crystals. Each cube is formed with uniform size, density, and strength.
The conditioned sugar is transferred to precision dosing systems. Each portion is measured to ensure identical cube weight and density. Uniform input guarantees uniform output. Newly formed cubes are still fragile. They are transferred carefully to avoid structural damage. At this stage, the cube exists, but it is not yet stable. The cubes enter a drying tunnel. Temperature steps low and harden without cracking. Moisture withdrawn, allowing cube defines durability and shelf life. After drying, cubes are cooled slowly.
Rapid cooling could cause internal stress.
Stability requires patience. Each sugar cube is inspected in real time. We check shape consistency, surface integrity, and weight accuracy. Defective units are only precision moves forward. Cubes undergo final stabilization checks, then move into packaging lines. Now, protection becomes the priority. Sugar cubes are counted and arranged using synchronized robotic systems. Order ensures efficiency.
Each set of cubes is wrapped in moisture-resistant material. Sealing is precise to preserve freshness. Protection from air means protection from humidity.
Wrapped units are grouped and placed into cartons. From individual cubes to organized units, ready for transport.
Each package receives a batch code. This ensures full traceability from production and back to all data. Finished products are stacked, wrapped, and prepared for shipment. From controlled production to global distribution. What began as a simple crystal became a precisely engineered form, measured, shaped, stabilized, and protected.
It starts in the field through process.
A small cube built on precision at every step.